This is 2.3 quadratic graphs, Vertex format. If you start out with f of x equals ax squared plus bx plus c. We wanted to find a list of things about this function. Where is the vertex? Where is the axis of symmetry? Where is the y-intercept? And where is the x-intercept? For the vertex, it's the opposite of b over 2a. And then f of the opposite of b over 2a. And we said the axis of symmetry was the opposite of b over 2a. And then when it came to the intercepts, things got a little bit complicated. For the y-intercept, we said let x equal 0. In other words, you find f of 0. So you take 0 and you plug it into the function, and whatever you get, that is your y-intercept. Most times that turns out being just the letter c. F of 0 equals c. And then for the x-intercept, we said you let y equal 0, which means you take the equation, you set it equal to 0, and you solve it. X squared plus 5x plus 4 equals 0. And remember, what we're looking for here are the x-intercepts, or the roots, or the zeros. On a graph, where does this function go through the x-axis? That's what we're looking for. So you do something like this, and you'd say x plus 4 and x plus 1, and then you would say x equals negative 4 and negative 1. And so those were your x-intercepts. And you knew that if you graphed the equation, you'd have one intercept at negative 1 and another intercept at negative 4. Then we went and changed it. And we changed this to a 3. And you said, okay, well, I'll try to FOIL it. I can't figure out whole number factors of 3 that give me a 5. And so we said, we're kind of stuck. And we introduced you to a new technique called completing the square. And what completing the square does is it takes something in standard format and it transforms it into vertex format. So completing the square takes an equation that's in standard and it puts it into vertex format. So we're going to run through complete the square with this guy. So the first thing that we do in complete the square is we put in some blanks. And I like to put, consider this blank to be a smiley face. I don't want to put an extra variable in there because sometimes that's confusing, but x squared plus 8x plus something minus 5 minus the same something. So we're going to add something and then we're going to subtract something. This is a little trick to keep everything balanced. And so what is the something that we need to add? And we said that the number that works is b divided by 2 squared. So you take your middle term, you divide it by 2, and you square it. And that's what you put in for the smiley face, and good things are going to happen. So in our case, that's going to be 8 divided by 2 squared, which is 16. So that means we're going to add 16 in the first blank, and we're going to subtract 16 in the second blank. And then believe it or not, this first chunk is actually a perfect square. If you factor it, you'll get x plus 4 times x plus 4, which is x plus 4 squared. In the event that you maybe have a nasty fraction, you can take this middle term, and remember when we divided it by 2 before we squared it? That number actually becomes the number that is part of that perfect square, x plus 4, x plus 4. That's not a coincidence. It happens every single time. Negative 5 and negative 16, I think that's negative 21 equals 0. So now we have x plus 4 squared minus 21 equals 0. And this is vertex format. And the reason they call it vertex format is because it fits this. X minus h squared plus k equals 0. And so our vertex in this parabola is going to be negative 4, comma, negative 21. So if we wanted to, we could sort of sketch this graph, figure out what it's going to look like. Negative 4 is probably there. Negative 21 is way down here. And that's your vertex. Negative 4, negative 21. So where's the axis of symmetry? X equals negative 4. F of 0 is going to be 4 squared minus 21, which is 16 minus 21, which is negative 5. So our y-intercept's at negative 5. I don't know, probably somewhere around here. 0, negative 5. And if you want, you could cross-reference that with the standard format that we had, right? Like if you look back at the original equation that we had, I bet you c is equal to negative 5. Yeah, right there. There's our y-intercept right there. And so we could have picked it off from there, or we could have done actually what we did here and actually calculate the y-intercept. So our y-intercept's negative 5. So now we know the vertex, we know the y-intercept. You're guessing that the graph probably is going to look something like this. But how can we find number 4, which are the x-intercepts? We'll find the x-intercepts. We just take this equation that we generated in vertex format, x plus 4 squared minus 21 equals 0, and we solve it for x. We move things around to get x by itself. So let's do that. So it'll be x plus 4 squared minus 21 equals 0. Add 21 to both sides. X plus 4 squared equals 21. Square root both sides. And then subtract 4. So x equals negative 4 plus or minus the square root of 21. So our left-hand x-intercept is going to be negative 4 minus root 21. And our right-hand x-intercept will be negative 4 plus square root of 21. This is negative 4 plus 4.6 and negative 4 minus 4.6. So here's the left-hand x-intercept, and here's the right-hand x-intercept. So once we're able to take that standard function and place it into vertex format, this is how we find all this information. Finding the vertex is incredibly easy. You just read it off the equation. X plus 4 squared minus 21 equals 0. Where's the vertex? Negative 4, negative 21. You read it right off of the equation. Where's the axis of symmetry? It's what's inside the parentheses with the x, negative 4. What is the y-intercept? Plug in 0 and calculate it. And then what are the x-intercepts? You take the equation, you set it equal to 0, and you solve it.